Hello, welcome to Media Unlocked. This is a special version of this today. We're going to talk about cables and connectors and how to make the worst ones work and the best ones work for you. My name is Neil Kesterson. I've been in the industry for over 25 years. I've been working on location during that time and also work in the studio. Our biggest problem on location are bad cables or bad cable hookup or mismatching, and even when we do these sessions we have to kind of match levels and cables to the equipment that we're using. On location it's a constantly changing environment, so you have to have different cables in your bag, different formats, different connectors, just to be ready for anything that comes along. First, I'm going to talk very general about electricity. If you need to know more, of course, go online, get a book at the library. But in general, electricity has a positive and a negative. So, for instance, if this is a battery and this is a light bulb, electricity flows out of this into the terminal, does its job, comes back, and it creates a circuitous loop. It must always go in a loop. With analog audio, it's the same thing. It's an electrical signal. Now, there are other ways to transmit audio from place to place, and that's fiber optics. But the general rule is the same with any kind of audio. You must create and finish the loop. We have, in the audio world, unbalanced and balanced. In the unbalanced world, we have a hot and a ground. It's sometimes called a negative, neutral, but in this case we're just going to call it ground. We have a positive, and that's a ground symbol. And notice it creates the loop. You have two wires, creates a loop. In the balanced world, we have hot and a ground, or negative or neutral, and then a shield. These two are the one that create the loop, and this is exactly what it says. It's a shield, it's a protector. It serves no electrical purpose for transmitting the signal. It only shields out any kind of RF or radio frequency or hum that is prevalent. It's all around us. Anytime we run an audio cable across the floor, for instance, near an electrical circuit, another electrical circuit, we can sometimes hear hum. Well, the shield in a balanced circuit helps to alleviate that. Unbalanced circuits or wiring is usually found in consumer equipment. Balance is usually found in professional equipment. You can have microphones wired as unbalanced. Mostly these are the kind that you might see on stage where a performer plugs in a microphone and plugs that directly into a guitar cabinet. You have a lot of buzz problems. For instance, electric guitars, they're unbalanced. That's why we have the hum problems. Balance are usually found in professional microphones. Types of connectors and cables in the unbalanced and balanced world. Unbalanced, here's an RCA. This is like consumer equipment. This is very typical of what you'd find on a stereo. We have the hot goes to the tip, and the ground or neutral goes to the sleeve on here. Again, we have the circuitous positive to ground connection with electricity. Here we have a 1/4 inch or a phone plug that has a positive and a ground, and the positive goes to the tip and the ground or negative goes to the sleeve. This is very typical. This is a mono plug, but it's also, for instance, you'd use it on a guitar or an instrument. Now we have balanced. On this side we have, for instance, a typical 1/4 inch plug. It's called a TRS or tip ring sleeve. We have the positive goes to the tip, just like the other one that we had over here, the guitar cable. But there's an addition, there's a ring right in the middle there. That's why it's called a tip ring and a sleeve. And then there's a sleeve. So the positive goes to the tip, the ground or neutral goes to the ring, and the shield goes to the sleeve. So you have the positive and negative through this, and then the extra shield through here. And the last one is a mic cable, an XLR, and there's 3 pins on that, and there's you have your hot goes to pin 2, your ground goes to pin 3, and your shield goes to pin 1. And there, you know, who knows why that is? There used to be a way to select what was hot and what was shield, and it was like a big wheel that you spun, and wherever the arrow landed, that was what you picked. But in recent years, in XLRs, and I say in recent years because it's a very old, it's probably a 50-year-old standard, but the last 20 years they've said, okay, here's the way it is. 1, 2, and 3 are configured like this. So we wire most of our equipment like this now. So in a studio environment, if you're going to install wiring, it will not be moved constantly over and over and over like it would on location. So you can afford to get plastic jackets, foil, shield, all that, and you save a lot of money. If you install something like this in your studio, the rubber jacket, it really adds to your expense. Now inside one of these we have coax cable. This is much like video cable. It has a connector like this. It's got actually a braided ground, so, and then it's got a plastic shield, and then just a really stiff copper coming out. This is just like what your cable company would install. It just has a different connector on it. Comes in varying degrees of thickness in all the cable in the jacket, but you will sometimes run across this in audio, especially if you're running digital audio. But I felt I must include this because occasionally you will run across that. In the balanced world, we've got, again, this is what you'd install in the studio. You've got your hot, your neutral or ground, and then you've got your shield, and the foil is a shield around this, or sometimes you have a separate unshielded wire that runs out. So you have 2 plastic covered ones, and then just a bare wire, and then a foil shield around it. This is not for location. Don't use these. You want to use the kind that have 2 rubber jacketed wires and then a braid. And this is what one of these looks like. We've got, this is an XLR, and we've got a rubber jacketed cable there. We've got a rubber jacketed cable there, and then we have a braid around this, and it's hard to see, but what we've done is we pulled the braid out, and basically you pick it out and create another wire with the braid, so it goes all the way around. And by the way, the wires that are inside the rubber jacketed are also twisted and braided together. So this allows a lot of flexing back and forth. Something like this, flexing with a straight wire that isn't braided, would break very, very easily. This takes a lot of abuse. And the rubber jackets help protect them from each other. The reason that it's braided is when you have wire that is wrapped around each other or twisted, it rejects RF or radio frequency and hum more than any other kind of wire that you can put together. In fact, the best kind of wire you can use on location has all this combined. It has not only one wire for the positive like this, it actually has 2 cables, 2 wires, rubber jacketed, and they are twisted together. You have, for the ground or neutral, you have 2 wires that are twisted together. They're separated and rubber jacketed. And then you have the braid that goes around all that you pull out. These are very high cost compared to any others, but the noise rejection is incredible. In fact, sometimes we actually use these in the studio only for our microphones. The brands that you'll find in this category that people are aware of are Megami and Canary. I'm sure Monster Cable has them as well. you're going to get a better deal with Megami and Canary. Basically the wires go and they twist together. Now let me quickly talk about connectors. The ones that are on this cable are Neutrik, N-E-U-T-R-I-K. Any kind of really good brand is going to serve well in the field. I like these because you can make your own cables very, very easily, and they pull apart and come together really quickly. They have really good tension control on them, meaning that you can pull on the cable and you're not going to pull it out of the soldering in there. And they even have some of these that are solder free, that you literally strip your cables and lay them down in the thing, and once you close it and twist it on, it pierces it. And they're very good for in the field. In fact, we even use them in the studio. We use them we can make cables very, very quickly that way. This is another Neutrik, but there's a difference between these two cables. This one I would use for analog audio, and this one I would use for analog and digital audio. The difference is in the cabling inside. Now you have, in electricity, you have a thing called impedance. The more impedance you have, the slower and more trouble electricity has to run through. It's like squeezing a garden hose. The water's going to have trouble getting out. That's high impedance. If I let go, that's lower impedance. So on analog audio, the impedance level can be kind of high compared to what digital has. Digital has much more signal going through, so we have to use low impedance cables. Do not run digital through one of these cables. The connector looks just the same. There is a little bit difference. This one has gold contacts on it, which allow or keep oxidation from happening and building up on them. But you can still use one of these connectors. It's the cabling that makes a difference. Now you can see there's some thickness on here, but that doesn't determine, like when we talked about microphones, you can't always tell by looking at a microphone exactly how it's going to perform. The same way with these, because this could have double twisted pair inside and be used as a microphone cable and not work as a digital cable. You have to look at, on this actually says 110 ohm digital cable. You can go down, 110 ohm works well for AES digital. You can go down to 75 ohm as well. 75 ohm is basically the same as a digital, video cable, video coax. But the secret is in the connectors. We have, remember we had hot, neutral, and positive. It works the same way, except with AES digital audio, you can actually get left and right down one of these cables. So it's like a stereo cable versus you would have to have two of these in the analog world to carry the same kind of signal down. So that's wonderful. Also in digital we have, these two look the same. Remember this cable? This is our RCA. This is a digital cable as well. And this is for a thing called SPDIF digital. Sony Philips Digital Interface is what it stands for, SPDIF. And it's like the consumer version of this kind of digital. It's lower quality, you can't run it quite as far, but it still is pretty good. It has a lot of limitations compared to AES audio, but it's still something that you find in a lot of even professional audio equipment. But here again, the difference is in the cable. It's not necessarily the thickness of the cable as much as it is the impedance or the ohms of the cable. This also has gold connectors. This allows us to connect and reconnect a lot of times, and guess what? This says Radio Shack on it, and it is actually a very, very good cable. You can find some good stuff at Radio Shack if you shop around. You will spend probably a little bit more than you would if you were to buy in bulk from a professional audio dealer, but for some places right around the corner, it's a pretty good deal. One last thing here, I have two mini connectors. They look very similar. Notice one is tip and sleeve and one is tip ring sleeve. And they're actually, the tips are a little bit different sizes. This is more what you're going to find, not necessarily on an iPod. This one might actually break an iPod. It's an 1/8 inch mini. This is 1/8 inch mini mono. And what I've done on the other end of these is put female XLRs, which allow me to plug in a microphone into this and plug this in a portable recorder. And you might, some of these, I go way back in this, but you have, we used to work with mini disc, but you still have some of your recorders that, like your pocket recorders that have the flash in it. They still have connectors on them. If they don't have a microphone connector, they might have a little connector in the top. And this is what I would use on that, because a microphone, I know, has 3 connectors, but inside we've wired it down to 2. This is the same thing, although one thing we've done on this one, we've added some special circuitry to it. We've added a resistor in here to knock down the circuit even more, to bring it down to mic level in little recording devices. But the safest thing to do is to grab one of these mono connectors, and when we go back to the positive, negative, and shield, we tied the shield and the negative or ground together into this from this, and then that's the only hot. And it rejects well. If I run that too long, we're going to run into problems. But this is mostly so you can stick a recorder in your pocket and have a microphone and do interviews or get it in real close. Okay, I'm going to talk about 2 things, and they both have to do with hum. One is avoiding hum and problems. This is an electrical cord. This is an extension cord, basically. And you're on set, and you have lights running through here. High power, 110 volts. This may even be 220 volts. You know, some sets have it. But let's assume it's a regular power cord. Can we start again? Let's start again.
Yeah, I need to reposition this. Alright, you're good.
Okay, start off. Okay, this, we're going to talk about how to avoid a problem and how to fix a problem. Both of them have to do with hum. You're on the set, you've got a power cord running across the floor, and you have to go the same direction. A lot of people just run the mic cable along the same path, parallel with it. Well, what happens, you pick up hum because this generates radio frequency. This does too, but this is much, much stronger. With audio cable, we're running about 1 volt AC. This is 110 volts AC, so this is much more powerful. The thing to do is stay at least 12 inches away from the power cord, and you're going to avoid it. But what if you need to go across the power cord? You come at perpendicular to the power cord this way. And another solution to a problem is you need to run your mic cable along this for a while, but you need to get across. Just again, maintain that 1 foot rule, and then cross over at 90 degrees at some point, and then go ahead and run onto your source. Don't ever do this. And the same thing goes for video cables. If you see a video cable laying there, it's a lot more powerful than an audio cable. It's carrying higher signal. Try to observe the same rule. You are going to get RF in there. And you know, with your audio cables too, if you run a whole bunch of your audio cables in a bundle, you run that same risk. Very low risk, but you still run that risk if one of the audio cables doesn't have good shielding. If you follow your location rules and you have good shielding, you should avoid a lot of those problems. The next problem is a troubleshooting thing. A lot of times you're going to plug in to a source, and you're going to have this problem. Let's say you've followed all these rules. Gone a lot through here. There's a couple problems you can have. It can be in your audio equipment. If you're plugged into the wall, you have the 3-prong connector on your AC plug. Go to the hardware store and get one of where it's called a ground lift. It's like a little gray thing you would put on the end, and it just has 2 prongs, and plug that in, see if that helps. The other thing is to have one of your audio cables that are coming in, you simply open it up and you cut that shield. Remember the braided wire that we had? I have one of those cables that's in my toolkit that I take along in every location, and I have it clearly marked on here that it has no ground, and I do it on the side, on the end that I'm going to plug into the audio equipment, the last possible moment where the mic is going to plug in and the ground is cut. So that way, if it's picking up any kind of RF, in my mind I think that it's going down and it drains off into nowhere. And I've had that actually explained to me by an electrical engineer. Yeah, it's called a drain. And that's ways around those kind of problems. Just get in there and clip it, sacrifice that cable, and then that one is in your kit all the time to kind of fix those problems. You do run the risk of the audio being a little bit thinner sounding, possibly, and there may still be some buzz in there, but a lot of times it knocks it down completely. If the buzz is still there, you've done your jack in the wall, you've done that, you've clipped this, you may have some other shielding problem in one of your cables. You just have to go through one cable at a time, pull it, replace it with another one. That's why it pays to take extra cables with you. That's it for the grounding. That's it for cables this week and connectors. Now the next time we're going to do something really exciting. We're actually going to do a location. This is what everyone's going to want to see. You're going to want to tune in for this because we're going to take you behind the scenes and we're going to show you how we really do it in the field. We're going to show you problems. We're going to have problems. And as we have the problem, we're going to solve it with you watching. So everything we do, you're going to see. You're going to hear what it would sound like if we just use a camera mic versus if we mic it properly. You're going to see all the stuff behind the scenes. All this is culminating to what we're going to do the next time. You have to watch this. Thanks for tuning in.